Hello, my name is Pico Soskar, and together with Sherman Camelia, we would like to present to you Bugsby, a tool support for bug triage automation. For today's agenda, I will go through the motivation behind our paper, trying to describe what are the problems that issue taking systems are facing in the context of bug triage. Then, we would like to propose a tool for solving these problems and will end the presentation with some conclusions and intended future work. The motivation behind our paper was the great importance that issue taking systems have on software development and software maintenance. Besides being able to track issues, bugs, and feature requests, these systems are now platforms where developers collaborate, share documentation and ideas, and visualize the progress of the project. Some of the most popular issue tagging systems are presented in this figure, and they are Jira, GitHub, and Bugzilla. Once an issue has been submitted, it is important to triage it, that is, to determine certain aspects of it, such as its severity, whether it is a duplicate or not, or if it is a valid issue. However, studies have shown that the number of issues that are submitted in trackers has grown massively. This means that manually inspecting issue reports will not only become more and more time consuming, but also more expensive for the organization which is financing the respective software project. This is further supported by the fact that the bug triage process is a difficult one in and of itself, as it requires knowledge about the software in question. As more people turn to software products, more issues will be submitted, turning manual bug triage into an impossible task. Now, for automating the bug triage process, our proposed tool is Bugsby. It is a web application serving as an issue tracking system which uses text mining to automatically process issue reports as they are submitted. Bugsby is generally available at the link below at bugsby.herokuapp.com. Where Bugsby innovates is in its workflow, in the way that issues are submitted. When a user tries to add an issue in the system, the application will present the user with the most appropriate severity level, all for a better prioritization of issues in terms of the resolution. This is done based on the title of the issue and is achieved using a machine learning classifier which was trained using naive Bayes. Afterwards, Bugsby will retrieve the issue's possible duplicates, which tries to ensure the report's uniqueness. And lastly, Bugsby will check for offensive language within the report. We felt that this last step would be necessary, as studies have shown that software communities are using a lot of offensive language online. As such, rejecting issues which contain high levels of such language would decrease the number of issues that need to be managed. This figure presents the architecture of our tool, composed of two major components. The first one, the data layer component, implements the functionalities that constitute the core of our tool, including features such as creating a new project or ensuring the persistence of the added issues. The other component, which we've named the AI component, determines an issue's most appropriate severity level, possible duplicates of the issue, and whether it can be considered offensive or not. As such, this component is central to our system's workflow. Each of these features requires a certain pre-processing of the issue's textual contents, such as punctuation symbol removal, stop word removal, text lowering, and text normalization. This is then followed by converting the resulting text into number vectors of word frequencies, with the vocabulary being given by the dataset the model was trained on. For severity prediction in particular, we have created a special data set. We have extracted issues from projects such as ActiveMQ or Log4j or Spring JPA and collected them into a single data set, which was later used to train the severity classifier. This table presents the content of the constructed dataset, which is available alongside the other datasets that were used inside Bugsby at the fixture link, which is down there. We have performed an empirical validation on our tool. For severity prediction, we have achieved an accuracy of 82% and precision, recall, and F1 scores of around 80% each. And for validating our duplicates retrieval, we have tested our component on various datasets which were collected by Abram Hindle and compared his results to ours in terms of recall and mean average precision. The results indicate that retrieving duplicates using the entire title of the issue as it is implemented in Bugsby performs better than the continuous querying variant which was proposed by Hindle, in which multiple queries are performed as the issue report is completed. And lastly, for the offensive language detector, which returns the probability of the issue to contain such language, we have computed the Briere score, obtaining one of 0.049 and a cross entropy loss of 0.186. Now, I'd like to offer you a hands-on look at Bugsby. As I've said, Bugsby is available at this link, and users are being redirected to a page where they can log in. After a successful login, they are being redirected to a page where they can view the projects they are actively working on. Via this menu, they can go to a page dedicated for the issues that have been assigned to them. Now, going back to the project page, each page of a project contains a section dedicated to the issues that have been assigned to them. For example, for this particular project, there are these 3 issues already submitted. Now, to demonstrate the workflow of Bugsby, I will need to add a couple more issues. Firstly, let's say we have this issue. The database is lost. And let's assume I'm not a technical person, so I may mark this as a trivial issue. Now, as I try to save it, the system detects that the severity that I have chosen is different than the one that the system would recommend, and displays this recommendation that critical and blocker severities might be best suited. Now I can either click this button and save the issue as I've reported it as a trivial one, or click this one and change the contents of the issue report as instructed. And the issue is saved successfully. What happened in the background is that a retrieval for possible duplicates was performed, none were found, and then a check for offensive language. Since our report did not contain such language, the issue was saved successfully. Now, to demonstrate the duplicate detector, I'd like you to pay attention to these 2 issues: no scrolling of document content by use of the mouse wheel, and unable to scroll with the mouse wheel, which are quite similar. They might be duplicated. And let's try to add another one which is similar to those 2. Let's say I am not able to use the mouse. As I try to add the issue, I am being redirected to a page where possible duplicates are displayed in the form of these 2 right here. Now I can go through each individual report and assess for myself if my issue is truly unique or not. If I do decide that my issue is truly unique, I can click this button and my issue is saved successfully. Now, to demonstrate the offensive language detector, you will need to excuse the language that I'm going to use. And more report is rejected as the title contained high levels of offensive language. In conclusion, issue tagging systems are of great necessity both to software development and software maintenance. Thus, important steps should be made towards automating the bug triage process to ensure a better management of them. Future work would be intended at integrating more features characteristic to issue tagging systems, making BugZip an even more comprehensive tool, and further automate the bug triage process. Thank you for your time.